Hey everyone, Kyle Walker here. If you love cars, fixing things, or just want to understand your vehicle better, you're in the right place. I share hands-on tips, smart driving advice, and straight-up car talk without the fluff. Make sure to hit that like button, subscribe to the channel, and stick around till the end. You don't want to miss what's coming up. Let's get into it.
When choosing a new or used car, always pay special attention to the engine. And here it is important not only power or volume, but also the type of motor, its structure, design, and manufacturer. The choice of engine directly depends on how economical the car will be, and how often the owner will encounter malfunctions. That is, the emphasis is on reliability and durability, and the secondary parameters are performance, economy, and number of horsepower. Quite interesting in the eyes of buyers looks the engine, which is labeled with the letters GDI. The abbreviation stands for gasoline direct injection. Here we are talking about the system of direct fuel supply to the engine. An important feature is the fact that the intake is not in the manifold, as it is done on the classic injectors, directly into the cylinder. Therefore, GDI is legitimately and fairly called a combination of diesel and gasoline systems. Features of the device. It has already been approximately told what GDI engines are and what their key feature is. But this does not allow you to fully understand the essence of the motor and the features of its device. Based on the decoding, you have understood what a GDI engine means and that the motor uses a combined system, which is characteristic of gasoline and diesel internal combustion engines. It is a kind of a mixture of two different motors, which means getting a certain advantage over the competition. It is not quite obvious to some motorists what a GDI engine is and what its peculiarities are in practice. The key nuance can be called the fact of working on a depleted mixture formed in the engine at low loads. They include even driving at a speed of no more than 120 kilometers per hour. But when the load increases, the system automatically switches to the classic injection system. Thus, it is possible to achieve better environmental performance and economy, which for many becomes a decisive factor in the choice. It is also worth noting that now there are turbo versions of GDI, which additionally received a turbocharger in its design. With its help, it was possible to increase power and performance, but at the same time to retain the ability to consume a small amount of fuel compared to competitors. And what is a turbo in the engine? Probably everyone knows. GDI engine paired with a turbocharger allows you to get an excellent result. Among car enthusiasts, there is a strong opinion that the first manufacturers of GDI-type motors is the Japanese company Mitsubishi. But in reality, it is not so. The first engine with such a system of combined injection was installed on the racing version of the German car W196, produced by Mercedes. After a while, the Japanese company used an electronically controlled injection system. Thus, they managed to achieve the formation of a depleted fuel-air mixture when the engine operates at low loads. For the first time, Mitsubishi cars with GDI engines appeared on sale only in 1996. Since that time, the engines have gone through a number of changes and modernizations, as the first samples had a wide list of shortcomings. To be fair, it should be added that the abbreviation GDI is used by the Japanese automaker Mitsubishi. Other companies also have motors with a similar system, only they produce them with other markings. French automobile concern Renault uses the concept of IDE, Mercedes has CGI, and cars from Toyota can be equipped with D4 engines. Operating principle. The principle of operation of any internal combustion engine is based on the fact that fuel is fed and mixed with air to form a fuel-air mixture. Without the participation of air or oxygen, ignition of the mixture is impossible. A gasoline power unit requires a mixture ratio of 14.7 to 1 for optimum performance. That is, 1 gram of fuel is required per 14.7 grams of air. If the amount of air exceeds this norm, the mixture is considered lean. If the amount of air is less, then the mixture is rich. Due to the engine operation on the depleted mixture, it is possible to noticeably reduce fuel consumption. But since there is rather little fuel in it, it is more difficult to ignite such a substance. Because of the inability to ignite the mixture, problems appear. But the mixture oversaturated with fuel is ignited very easily. But at the same time, gasoline is not burned out completely, and the unburned part comes out with the exhaust. Hence, overconsumption of fuel and irrational use of gasoline. Additionally, enriched mixture contributes to the accumulation of carbon deposits on the engine valves and spark plugs. Taking into account all these points, you can understand the principle of operation of GDI engines and understand their distinctive features. The design difference is that the injection is not directly into the intake manifold, as is the case with conventional injector gasoline engines, but directly into the combustion chamber. This principle is borrowed from diesel engines. The operation of GDI can be described as follows. Gasoline enters the combustion chamber under the influence of high pressure. The flow itself is characterized by its swirling shape, which is achieved through the use of special nozzles. They differ from the usual ones in their structure. The fuel flow under high pressure meets resistance from the piston. A collision occurs. This allows part of the fuel to remain on the surface of the piston. The rest of the gasoline continues to move on, creating a frictional force and taking on a certain shape. The flow then curls and moves away from the piston with a parallel increase in velocity. Some of the particles move slower and they begin to diverge to the sides, thus dividing the flow. As a result, two areas with a fuel-air mixture are formed simultaneously inside the combustion chamber. In the middle there is a zone with a normal flammable mixture, and around it there is a depleted substance. The cycle is completed by ignition, which is formed by the spark plug, borrowed from the injector gasoline engine. First, the section with the standard mixture is ignited, and then the depleted fuel with air is burned. Read also how the new generation of ignition system switches work to create these conditions. The entire process is controlled by a special sophisticated electronic unit with special software capable of carrying out several different cycles of operation. The design involves vortex nozzles. It is with their help that it is possible to feed inside the chamber a mixture that resembles, in its consistency, a finely dispersed fog. While in the classic or standard sense the fuel/air mixture has a ratio of 1 to 14.7, GDI uses a mixture of 1 to 20 when operating under low loads. This results in good fuel economy. Distinguishing features. To understand the difference between GDI and conventional injection systems, it is necessary to consider the distinctive characteristics of this engine. In this way, it will be possible to learn the key points about the gasoline motor with direct injection. The injection process is carried out under pressure, which has parameters from 50 atmospheres and more. In classic systems of injector motors, the pressure is about 3 atmospheres. Such a supply allows you to create a finely dispersed mist when spraying. There are some design differences related to the throttle valve. In GDI-type motors it is installed a little further away. Fuel is fed directly into the slave cylinder itself, where a mixture of fuel and air is formed. On conventional engines, however, the fuel is fed through the intake manifold, which is also necessary for the creation of the fuel-air mixture. In the design of pistons there are recesses of spherical shape. Due to it, it becomes possible to create swirls and control the flame during ignition. Additionally, the recess is needed to control the creation of the mixture, regulating the necessary volume of air and fuel when they are combined into a mixture. GDIs allow the creation of very lean mixtures. On modern engines, it is possible to work efficiently even on a mixture whose proportions are up to 43:1. This is despite the fact that classic fuel systems are characterized by a ratio of 14:1. Special vortex nozzles are installed in the cylinder head. With their help it is possible to create flows of twisted shape. As a result, the flow movement is carried out along a strictly defined direction and trajectory. GDI engines are characterized by the ability to operate in 2 different modes. These are normal mode, as in a standard injector, and depleted mode. And the transition from one mode to the other is automatic. When the engine increases the load, i.e., starts to move at a higher speed, the enriched mixture is fed. In the quiet mode, the lean mixture is burned, thus saving fuel. In the composition of such a motor, the fuel pump takes an obligatory part. Moreover, the high-pressure fuel pump is given special attention because it acts as a key element in the operation of the direct injection system on GDI and similar. The pump affects the quality of functioning of the power plant and its entire performance. Everything looks very interesting and attractive from the position of a potential buyer of a car with such an engine. But for objectivity, it is necessary to consider the strengths and weaknesses of the GDI motor. This will allow you to fully assess the capabilities of the engine, taking into account all the available disadvantages. And then it will become clear whether it is worth buying such a car or not. The main advantages. Having studied the pros and cons of GDI engines, you can draw some conclusions about these powertrains and the fuel supply system used. The engine derives all of its key benefits from its ability to run on a leaner mixture at low and medium loads. Changing the fuel/air ratio helps to reduce the amount of fuel consumed. As studies have shown, in the urban cycle, the consumption drops by 20 to 25% when operating at approximately the same speed for a long time. But GDI does not get similar advantages on the highway when the speed and engine load increases. Here the consumption remains at the level of conventional injector systems. Another advantage is the process of mixture formation, which takes place inside the combustion chamber. Any specialist in engine repair and maintenance will tell you that the combustion process in the cylinders is always uneven. The greatest amount of fuel is burned near the plug, but on the far side, the fuel may not be burned, and as a result, the residue escapes through the exhaust system. GDIs are devoid of this disadvantage, as are modern TSI motors. The technology of layer-by-layer injection is used here. As a result, it allows injecting up to 5 portions of fuel per cycle, forming a heterogeneous mixture in the cylinders, taking into account specific combustion characteristics. This helps to reduce consumption, reduce the toxicity of the emitted exhaust, and maintain stability at low and medium engine speeds. Read also, what is the fuel injector on a diesel engine, how it works, in what varieties is available, a special process of mixture. Formation forms another advantage, which is expressed in the form of an increase in power and traction. The increase in these parameters is about 10 to 15%. Additionally, GDI is characterized by a smaller amount of formed carbon deposits, which automatically extends the service life of many components of the engine. In case of competent operation, the oil also retains its properties up to the replacement period stipulated by the manufacturer. Observing all the rules and conditions of operation, the probability of serious malfunctions is reduced, which positively affects the durability of the engine and reduces the financial costs of operating a car equipped with GDI. Characteristic disadvantages. But no system can do without certain disadvantages. Therefore, it is worth to know in advance what is so bad GDI engine, what is its main disadvantage, and to what extent the disadvantages outweigh the advantages, or vice versa. Let's start with the fact that GDI engine uses a more complex system of fuel intake, in the design of which there is a fuel injector, similar to those used on diesel engines. As a result, a disadvantage manifests itself in the form of increased sensitivity to the quality of the fuel used. This refers to the inclusion of various solid components, iron compounds, phosphorus, sulfur, and other substances in gasoline. If you regularly pour low-quality fuel, the engine will start to break down. The engine with direct injection system has another disadvantage. It consists in the fact that the technology is quite specific, and only a limited number of car services can offer their services for repair and maintenance of such internal combustion engines. Repair procedures differ in their complexity compared to conventional injector engines with distributed type of injection. Owners of cars with GDI powertrains are faced with the fact that there are few spare parts available on the market. Parts for them are not very common in our country. Therefore, sometimes, when there is a breakdown and the need to replace the element, it has to be ordered and waited for several weeks, which automatically does not allow you to operate the car. Taking into account all these points, you should carefully think about the rationality of buying such an engine, because you will have to solve the issue of repair, maintenance, and search for good gas stations, problems and malfunctions. In fact, almost all the problems that the GDI engine has are related precisely to the issue of sensitivity to low-quality gasoline. Such a feature leads to the appearance of various breakdowns and malfunctions. As the experience of car owners shows, spark plugs on GDI motors start to turn black and fail. The fuel system does not like when water, various mechanical impurities, and solid mineral particles get inside. It also causes soot on the surfaces of the valves and intake manifolds. As a result, The process of mixture formation changes, which is caused by the disruption of the flow path inside the cylinder. All this leads to reduced power and interruptions. In order not to provoke such malfunctions, and to provide the GDI motor with a long and effective work, it is recommended to perform some preventive measures. They are reduced to observance of the following rules. It is recommended to change the spark plugs even before malfunctions occur. In our operating conditions, the optimal inter-service period is considered to be 10 to 20,000 kilometers. In addition, it is recommended to clean the intake manifold from accumulated carbon deposits and soot. This is done at least once every 25 to 30,000 kilometers. Be sure to monitor the condition of the injectors, check the quality of fuel atomization, and clean the injectors. Taking into account the available disadvantages, it is hardly worth saying that when operating GDI, it is extremely important to visit only proven and well-established gas stations that offer the highest quality, clean, and undiluted fuel. Rationality of purchase. Potential buyers of cars with direct fuel injection, which is used in the GDI system, are attracted by its economy, good traction, and excellent power indicators. But as a counterbalance, several disadvantages can be put at once due to the drop in reliability under the influence of low-quality fuel. Objectively, the operation of such engines in our conditions can lead to the fact that the owner will need to regularly visit the service station, spend a lot of money on repairs, and long wait for the delivery of necessary spare parts. But this was relevant before. Currently, the situation is changing for the better. Engines produced by foreign manufacturers undergo an adaptation procedure. This allows to reduce sensitivity to gasoline quality, to process even not the best fuel, and to reduce the number of problems. Adapted GDI can be safely refueled at all fairly good gas stations, without fear that any impurities will lead to a very rapid engine failure with subsequent impressive material costs to restore the performance of the power plant with direct fuel injection system. Whether to buy vehicles with such motors or not is a matter for everyone personally. Engines that have undergone adaptation are much more attractive than European or Japanese versions. It is possible to get a number of advantages from GDI. The owner will only need to remember the risks of visiting dubious gas stations, as well as comply with all prescribed recommendations. And advice on operation, maintenance, and replacement of consumables. Under such conditions, GDI will show all its best qualities, and you will hardly remember about characteristic shortcomings. In conclusion, gasoline direct injection, or GDI, engines represent a significant advancement in automotive technology, offering improved fuel efficiency and enhanced performance. Their design allows for precise fuel delivery directly into the combustion chamber, which optimizes combustion and reduces emissions. However, while GDI engines provide notable advantages, such as better power output and lower fuel consumption, they also come with challenges, including potential carbon buildup and higher manufacturing costs. As the automotive industry continues to evolve, understanding these aspects of GDI engines will be crucial for consumers and manufacturers alike, as they navigate the balance between performance and sustainability in modern vehicles. Thank you for watching, and we hope this video has provided valuable insights into the world of GDI engines.